Scientific Revolution. The Scientific Revolution was a period of drastic change in scientific thought that lasted from 1450 to 1648. Prior to the Scientific Revolution, most people held a medieval view of the world, meaning that it was primarily religious and theological. Moreover, political theory was based on the divine right of the king, and society was largely governed by religious views, traditions, and practices. Superstition also played a major role in the everyday lives of the people. Until the 17th century, people were largely influenced by Aristotle and the geocentric view, which stated that the Earth was the center of a static, motionless universe. In a sense, science was a branch of theology. Causes of the Scientific Revolution. By 1300, medieval universities started providing the framework for the scientific revolution, as philosophy had become an accepted discipline in addition to law, medicine, and theology. Medieval philosophers developed a degree of independence from theologians and a sense of free inquiry. Leading universities even established new professorships of mathematics, astronomy, and physics within their departments of philosophy. Major scientific figures either studied or taught at universities. Furthermore, the Renaissance stimulated science by rediscovering ancient mathematics. This is because the Renaissance patronage was often scientific as well as artistic and humanistic. In addition to this, navigational problems on sea voyages in the age of overseas expansion created a need for scientific advances. New instruments such as the telescope, barometer, thermometer, pendulum clock, microscope, and air pump were developed during this time. Gresham College in England, scientists worked closely with top officials in the Royal Navy and leading merchants and shipbuilders. Gresham College became the main center of scientific activity during the first half of the 17th century. New scientific methodology also impacted the scientific revolution. For instance, Francis Bacon formalized empirical and experimental research, whereas René Descartes emphasized deductive reasoning. Astronomy is one of the pillars of the scientific revolution. Nicholas Copernicus, who wrote on the revolutions of heavenly spheres, spearheaded this science by introducing the heliocentric view. Copernicus argued that the Earth revolved around the Sun and that the Sun was the center of the universe. With this view, Copernicus directly challenged Ptolemy's 2nd century AD view of a geocentric universe. Heliocentrism seemed to challenge the Bible's book of Genesis, which puts forth a geocentric view. Martin Luther and John Calvin condemned Copernicus' theory. They pointed to biblical passages supporting the medieval law of geocentrism. By 1616, the Catholic Church had proclaimed the Copernican theory as false and persecuted those who advanced his view. Tycho Brahe and Johannes Kepler. Tycho Brahe was Europe's leading astronomer in the late 16th century. He built the best observatory in Europe and for decades collected massive data on his observations of the universe. This data became a cornerstone of astronomy for centuries, and later even proved Copernicus' theory. Ironically, Brahe did not accept the Copernican theory. He believed that while planets all revolve around the Sun revolves around the Earth. Johannes Kepler was the first great Protestant scientist who earlier had worked as an assistant to Brahe. Kepler mathematically proved the Copernican theory and developed the 3 laws of planetary motion. The first law states that the orbits of planets are elliptical, not circular. The second law states that planets do not move at uniform speed while in their orbits. The final law states that the time it takes for a planet to orbit the Sun is directly based on its distance from the Sun. The onset of the 17th century led to many advancements in astronomy. One of the most well-known astronomers of this period was Galileo Galilei. Galileo developed the laws of motion. He used the experimental method and found that all falling objects descend with equal velocity regardless of their weight. Moreover, he discovered the law of inertia, which says that an object that is in motion remains in motion until it is stopped by some external force. He validated Copernicus' heliocentric view with the aid of a telescope. However, his views were largely supported in Protestant Northern Europe, where reformers had questioned Catholic doctrines. In 1632, Galileo published Dialogue Concerning the Two Chief World Systems, in which he wrote about the Copernican system as a mathematical proposition. In 1633, the Inquisition of Pope Urban VII forced Galileo to retract his support for the Copernican theory. He was forced to remain under house arrest for the remainder of his life. Another influential astronomer was Isaac Newton. He incorporated the astronomy of Copernicus and Kepler with the physics of Galileo into an overarching theory explaining order and design to the universe, which included the principle of universal gravitation. Newton also developed a set of mathematical principles to explain motion. One was that every body in the universe attracts every other body in the universe in a precise mathematical relationship. Since these natural laws are unchangeable and unpredictable, God's active participation in the natural world is not needed to explain the forces of nature. This directly challenged medieval beliefs and even came to be the foundation of the Enlightenment view of God, deism. The scientific method. Francis Bacon, who was mentioned earlier, formalized the empirical method that had already been used by Brahe and Galileo. Bacon's method, coupled with Descartes' deductive reasoning, formed the backbone of the modern scientific method. Descartes' scientific method depended on logic alone, and he believed that science must start with clear and incontrovertible facts, and subdivide each problem into as many parts as necessary using a step-by-step logical sequence. Anatomy, physiology, and biology. Scientists began challenging traditional Greco-Roman medical theories of health and disease, such as the 2nd century Roman physician Galen. Galen believed a proper balance of the four humors, blood, phlegm, black bile, and yellow bile, were the basis for human health. Bloodletting was also a common method used to place the humors back into proper balance. One of the modern physicians was Paracelsus, who was a Swiss physician and alchemist. He was a pioneer in the experimental method in medicine and experimented with the use of various chemicals and drugs to deal with medical issues that he saw as chemical imbalances rather than humoral imbalances. Another modern physician was Vesalius, who wrote The Structure of the Human Body, published in 1543. His book renewed and modernized the study of human anatomy. Vesalius dissected cadavers, many of whom had been criminals, to achieve stunning detail in his drawings, and was the first to assemble human skeletons. William Harvey was an English royal physician who published On the Movement of the Heart and Blood in 1628. It explained how blood was pumped by the heart and circulated throughout the body via veins and arteries. Furthermore, Anton von Leeuwenhoek, also known as the father of microscopy, developed powerful microscopes. He was the first to see and write about bacteria, yeast plants, and living organisms in a drop of water, and the circulation of blood corpuscles and capillaries. Royal Scientific Societies. Governments and monarchs encouraged scientific inquiry as a means to further the prestige of the state and remain at the cutting edge of technology. Scientific societies created a means by which scientists could communicate with each other internationally. This helped forge a powerful international scientific community. The Royal Society in England was perhaps the most successful and prestigious and was founded in 1660. Other royal societies were created in Naples, France by Louis XIV, Prussia by Frederick I, and Russia by Peter the Great. The impact of the scientific revolution. The scientific revolution led directly to the Enlightenment of the 18th century. It also led to improvements in exploration. For instance, John Harrison's chronometer gave mariners the ability to easily determine longitude by the late 18th century. The spirit of experimentation helped accelerate the agricultural revolution near the turn of the 18th century. Moreover, improvements in medical knowledge helped improve the quality of life in later centuries. The scientific revolution also reduced the support for witch hunts by discrediting superstition and witchcraft as fallacies. Alchemy and astrology continued to appeal to elites and some natural philosophers, in part because they shared with the new science the notion of a predictable and knowable universe. Alchemy was the medieval forerunner of modern chemistry, as it dealt with the supposed transformation of matter. No clear line between alchemy and chemistry existed in the 17th or 18th centuries. Prominent leaders such as Queen Elizabeth of England paid alchemists and astrologers to forecast their futures. Both alchemy and astrology experienced a decline during and after the Enlightenment in the 18th century. However, in the oral culture of peasants, a belief that the cosmos was governed by the divine and demonic forces persisted. Everything in the universe, people, and the world seemed interconnected. Astrology coexisted with religion, magic, and science. This persistent belief in magic was one reason the witch hunts continued well into the 17th century. Thank you for listening. If you found this video helpful, please like and subscribe for more educational content.